Alright guys, some of this stuff is going to be familiar from what we've done before. We're going to combine section 7.2 today and section 7.6 and pick and choose out of both to combine it. So we're going to talk about transformations, and we're going to specifically talk about dilations. Alright, so let's just remind ourselves what a dilation is. It's going to be a transformation that changes the size of the figure but not its shape. Alright, you have your pre-image and your image that are always going to be similar. That's important. It's always going to be similar when you take something and you blow it up or you shrink it. Your scale factor, and you guys saw this before, is going to tell you how much the figure is reduced or enlarged. So if I blow it up times 2, then I'm going to multiply all my coordinates times 2. If I reduce it by 1/2, I'm going to multiply all my coordinates by 1/2. And that's what this tells me down here. So if k, your scale factor, is between 0 and 1, for example 1/2, then it's going to be a reduction. If k is bigger than 1, for example 2, then it's going to be an enlargement. It's going to take that ball and shrink it or reduce it. The other thing I want y'all to get down is that with your scale factor, it's going to be the reciprocal of your similarity ratio. And that is something that's going to come into play as we get through this lesson. So just keep that in mind and jot it down. I think that'll kind of help you as we do some of these problems. This is just something that to visualize what we just said. Okay, your enlargement, if I go from my pre-image, which is A, and blow it up, I multiply the coordinates by 2, for example, then you can see it enlarges it. If I start with A as my pre-image, and K is going to be 1/2, less than 1, but greater than 0, what it's going to do is it's going to shrink it. It's going to take all those coordinates and cut them in half. So the first thing we'll do is we'll just kind of practice using this, and then we'll extend it from there. So we want to apply the dilation to the polygon with the given vertices and describe the dilation. Alright, so we're dealing with a scale factor of 2 here, which you can see. And all I'm going to do is I'm going to take A prime, I'm going to multiply this by 2 so I get 4. I'm going to multiply this by 2 so I get 2. I have B prime. This is how I want you guys to write it up. This is going to become 4, this is going to become 6 because again I'm multiplying each coordinate by 2. And then I have C prime. Multiply this by 2 and multiply this by 2. And you're going to get 10 and 2. So these are going to be the new vertices. And then this is a dilation with a scale factor of 2. And just FYI, this is of course an enlargement. You could have told me this without even doing anything by looking at your original problem. So if you guys check this out, because of the fact that this is less than 1, this is going to be a reduction. And it's a dilation, of course, because you're dealing with the scale factor of 2/3. And then you would just take 2/3 and multiply it to each coordinate here. So this is something for y'all to keep in mind. We know with the dilation, the image and the pre-image are going to be similar. So your corresponding sides are proportional and your angles are congruent. Alright, there's your definition of similarity that we dealt with a couple days ago. However, with your translations, which is your slide, your reflections, which is a reflection over a mirror, and your rotations, you're going to be congruent transformations. So they're congruent because they just take the same exact shape and size, and they move them around the coordinate plane. The dilation is going to be a similarity transformation because it takes that figure and it expands it and contracts it, and it keeps the figure similar, but it isn't going to make it keep it congruent. So what we're going to do now, guys, is we'll go backwards. Now, in order to figure out what your scale factor is going to be, it's important that you notice the order that the problem has it in. Because your scale factor can change based on if you're going from the smaller to the larger polygon or if you're going from the larger to the smaller polygon. Alright, so it's basically asking you to determine whether the polygons with the given vertices are similar. So I'm going to go through, guys, and I'm going to say, okay, if I'm going from A to H, here's your A to your H, do I have the same ratio? This is my similarity ratio, 3 to 2, 3 to 2. If I go to my other vertices, if I go from B to J, then I also get 3 to 2. And if I go from 6 to 4, I get 3 to 2. Okay? Likewise, if I go from C to K, I get the same similarity ratio. And then if I go from P to L, I get the same similarity ratio. Okay, so because of the fact that I have the same similarity ratio for all of my sides, then yes, this polygon is going to be similar, or these two polygons are going to be similar. Alright, so your answer to this question is essentially yes. And this is what you're basically kind of doing in your head, or doing some scratch work off to the side. Alright? Let's go through and see a counterexample here. So it's asking me if PQRS is going to be similar to WXY Z. So we'll go through the process. I'm looking at P to W. Okay, so I get 2/5, 2/5. Okay, so now let's go from Q to X, because that's going to be the, Q to X, and that's going to be the corresponding vertex right there. So I get 2 to 5. However, look what happens when I do the Y values. My ratio is going to be 4 to 9. So based on the fact that I don't have the same similarity ratio for each vertex, the answer is going to be no. These polygons are not going to be similar. This is just a little note, you guys. All circles are similar because they have the same shape. In the book, they go through some process to show you that, but we're going to kind of keep moving so we can get 7, 6 in as well. Okay, but this is an important point that you guys need to keep in mind. So we're going to change gears a little bit, y'all, and we're going to talk about dilations and similarity in the coordinate plane, and just extend a little bit of what we just did a second ago. Alright, so these are what these problems are going to look like. You have to be careful here. Now, I'm going to tell you that when you go in order to figure out what your scale factor is, you're going to go from the first to the second. That's going to matter because if I'm taking this AOB and I'm expanding it to COD, then I'm enlarging this triangle because I'm going in this order. Alright? So I know, here's my AOB, and I'm just going to take it over here just so we can see what's going on. And I know that this is going to be 3 units, and I know this is going to be 2 units. Okay? And I know it's telling me that it's similar. So I know that my sides are going to be proportionate. Now let's go ahead and let's get COD down. Here's C, here's O, and here's D. And this is what we're trying to find. We know that C is going to be 4 based on our coordinate plane. But I want to find X. So you're just going to set up a simple proportion. I know that 2 coincides with 4, and I know that 3 coincides with X. So you're cross multiplying and you get X equals 6, which means that this ordered pair right here is going to be 6, 0. Alright, so coordinates of D are 6, 0. I checked that box. Now here's where you have to be careful, guys. Our scale factor is basically just what your similarity ratio is going to be, but it's going to be the reciprocal. Alright? So my similarity ratio from AOB, from my small guy to my large guy, is 2 over 4, which simplifies to 1 over 2. So your similarity ratio is 1 over 2. What did I tell you before? Your scale factor is going to be the reciprocal of that. So your scale factor is going to be 2. Alright? Basically, if I take the coordinate of AOB and I multiply it by 2, I get 4. If I take the coordinate of B and I multiply it by 2, I get 6. So my ratio of going from small to large is 1 to 2. The scale factor is going to be 2. Let's do one more of those just to drive the point home, because this to me is what can be confusing out of this section. So I have MON, and I'm going to do the same thing that I did before, and then I have POQ. And again, I'm going from my small to my large. Alright, that's the order it wants me to go in. So I have P, O, Q, I'll go ahead and get down what I have. P is going to be 15 units. All right. Q is going to be 30. I'm just getting this from my coordinates, and M is going to be 10. Okay, so what's it want me to find? It wants me to find the coordinate M. So I'm going to go ahead and I'm going to call this X. I'm not using this because of the fact that I don't have anything to compare it to here. Okay, so I know that these guys coincide. 10 over 15 goes along equals X over 30. Cross multiply, you get X equals 20. All right, so this coordinate right here is going to be 0, negative 20. Be careful, don't put a 0 in the wrong spot. Don't forget to put a negative because you're on the coordinate plane. Now, I know here, guys, this is what we have to be careful with. My similarity ratio going from my smaller to my larger is going to be 10 over 15, which simplifies to 2 over 3. However, the scale factor is going to be the reciprocal, 3 over 2. And that's what the question is asking them, for the scale factor. All right, so basically, if I take my smaller number, or my smaller coordinate, and multiply it by 3 halves, then I'm going to end up getting 15. That's a way you can check and make sure that when you're going from one to the other, that your scale factor is in the right order. All right, so this is the last thing that we'll go over, guys. We're going to go over it quickly, and then we'll talk about it a little more in detail tomorrow, but I want you to see it. So it's basically giving me all of the coordinates for A, B, and C. And it's giving me all the coordinates for D and E. All right, it wants me to show that ABC is similar to ABE. Okay, so the first thing you're going to do is plot your points, make sure they're already plotted. And you'll just have one of these in your homework. It's a little tedious, but I do think it has some good stuff in there. The next thing you're going to do is you're going to use your distance formula, not your DA, your DF, to find the side lengths, and I already did that. Again, you can do this tomorrow in class, and we can talk about it individually if you need to. And after you do that, guys, you end up getting this is 2 root 2, and you end up getting this is root 5, and then you end up getting that AD is going to be 4 root 2, and you end up getting AE is 2 root 5 after you go through and use all your distance formulas. Okay, so now what we want to do, and this is where it gets just a little tedious, we want to show that AB is similar to AD. We want to show that AC is similar to AE. Because we already know that angle A, by the reflexive property, is congruent to itself. Alright, so we'll get there in just 1 second. So I know that AB is 2 root 2. Don't get freaked out by those square roots. 2 root 2 over 4 root 2 is going to simplify to 1 half. And I also know that root 5 over 2 root 5, the roots cancel, simplifies to 1 half. So I've shown that my two side lengths are similar. Now I just need to write up that angle A is congruent to angle A by a reflexive property of congruence. And therefore, I can go ahead and I can conclude, just by my work here, that these are similar by side, angle, side, similarity. Oh, I can write it correctly. Alright, so again, the main thing here is just kind of remembering our distance formula, playing around with that, because that's something that we want to keep in our brain. Alright guys, so this is going to be your homework, and we'll work on in class tomorrow and recap everything that we just went over.